Good everyone, welcome to the amazing section with the Elite Tutor, where learning is made extremely very simple. And in today's video, we are going to be looking at the laws of indices part 3. And we are going to be solving questions where WAEC set their trap. Now in this video, we are going to be solving 3 questions. And these 3 questions combines the laws of multiplication, combines the quotient law, the power of product law, the power of power law. So we're going to be looking at how to solve it. Solving a question that combines multiple laws. So please, I want you to pay attention and follow to the end. Now we have the first question. We are asked to simplify. We have 2 raised to power 5 multiplied by 4 raised to power 2 divided by 8 raised to power 3. Now we are asked to solve this question. Now the first thing we are going to do, we are going to look at the numerator first. We are going to solve the numerator part of the question. Now this numerator part of the question says 2 raised to power 5 times 4 raised to power 2. Now we can't apply the product law or the multiplication law of indices. Why? Because their base are different. But it's possible that we can what? We can simplify this 4 raised to power 2 to look like what? This 2 raised to power 5. And how do we do that? We are going to express it in terms of 2. And that is where the definition of indices comes in. Now, we can say that this is 2 raised to power 5 times, now 4 can be expressed as 2 raised to power 2. Because 2 raised to power 2 gives us 4. So we know that 4 can be expressed as 2 raised to power 2. And don't forget to have this power. Please, I don't want you to get confused. Please pay attention. 4 itself has a power which is 2. That's one. It's a number which has a power which is 2. But wanting to express 4 in terms of 2, it is expressed as 2 raised to the power of 2. So 2 raised to the power of 2, all raised to power what? These 2. Now we can go ahead to further simplify that this is 2 raised to power 5 times. Now if we look at this 2 raised to power 2, all raised to power 2, we can see the power of power law. The power of power law says that when a power is raised to another power, what do? We simply what? Multiply both powers. So we're going to have that this is 2 raised to power 2 times 2. So we have that this is 2 raised to power 5 times 2 raised to power 2 times 2 gives us 4. Now we can see that we can comfortably apply the product law of indices while their base are same and they are multiplying. And the product law tells us when they are multiplying, what do? We go ahead to add their powers. So I'm going to have that this is equal to 2 raised to power 5 plus 4, which gives us 2 raised to power 9. Don't forget, all we've just solved is just the numerator. Now we go and now we've solved our numerator. Let's look at our denominator. Now these are denominator for short. So our denominator is 8 raised to power 3. Now this is 8 raised to power 3. We can express 8 raised to power 3 in terms of 2. We can express 8 raised to power 3 in terms of 2. How do we do that? We have that 2 times 2 gives us 4. Now times 2, so 2 times 2 gives us 4. 4 times 2 gives us 8. So that means expressing 8 in terms of 2, we are going to have that this is 2 raised to power 3. So expressing 8 in terms of 2 is 2 raised to power 3. Why? 2 times 2 gives us 4. 4 times 2 gives us 8. So we are going to have that this is equal to 2 raised to power 3 all raised to power 3. So here we are going to see apply the power of power law. So we are going to have that this is, we are going to have that this is 2 raised to power 3. Power law say that when we have a power raised to another power, we multiply both power. So 2 raised to power 3 times 3. So we are going to have this is 2 raised to power 3 times 3 gives us 9. So we have 2 raised to power 9. So don't forget, we've been able to solve that our denominator gave us 2 raised to power 9, and our numerator gave us 2 raised to power 9, and our denominator, which is 8 raised to power 3, after undergoing simplification, it has given us 2 raised to power 9. Don't forget, this is a division sign. So we now have 2 raised to power 9 divided by 2 raised to power 9, which is the same thing as 2 raised to power 9 divided by 2 raised to power 9. Now what are we going to do? Now we can go ahead to apply the quotient law. How can we apply the quotient law? Because their bases are same. And because their bases are same and then we are dividing, what are we going to do? We are going to subtract their powers. So we are going to have that this will be 2 raised to power 9 minus 9. 9 minus 9 gives us 0. So we're going to have that this is 2 raised to power 0. And this will not be our final answer. Don't forget, the 0 index law says that any number raised to the power of 0 gives us 1. A raised to the power of 0 gives us 1. So we now have that 2 raised to the power of 0 gives us 1. And then our final answer is 1. Why am I not setting this kind of question? Why? This kind of question, you can see that it combines multiple laws of indices. It tests the student ability on the different laws of indices. Here we apply the multiplication law of indices, we apply the period law of indices, we apply the power law of indices, and also the 0 index law, about 4 laws in this particular question. And our final answer gives us 1. Now our next question, we are going to be simplifying 16 raised to power 3 over 2 divided by 8 raised to power 4 over 3. Very simple. Now let's solve. Follow closely. So we have 16 raised to power 3 over 2 and 8 raised to power 4 over 3. Now what do we do in this kind of question? Most students, when they see that a number is being raised to a fraction, they get confused. No, that's why a little tutor is here. Now I want you to pay attention. Now first thing, let's take out the whole number in each of this one, the fraction. The numerator here we have 16, while the denominator we have 8. First thing we want to do, let's express both of them in terms of 2. Now we are going to have that our numerator, which is 16. 16 being expressed in terms of 2. We are going to have 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. That means expressing 16 in terms of 2 gives us 2 raised to power 1, 2, 3, 4. 2 raised to power 4. And if you are asked to express the one number here in terms of 2, this is what? 2 times 2 gives us 4, and 4 times 2 gives us 8. So 8 in terms of 2 gives us what? 2 raised to power 3. Now, we'll be able to express these whole numbers. Now we can go, instead of using 16, we'll use 2 raised to power 4, and instead of using 8, we'll use 2 raised to power 3. Now follow close. Now we can rewrite this expression to be, our numerator is 2 raised to power 4 all raised to power 3 over 2. divided by, instead of using 8, we now have 2 raised to the power 3. We now have 2 raised to the power 3, all raised to the power 4 over 3. Now, at this point, we can now introduce the power of power law. When the power here is 4, is raised to another power, which is 3 over 2. What do? We multiply both powers. Now, let's multiply. Now, the powers we have here, please follow closely. Let's do some rough work here. We have the power here is 4 times 3 over 2. So, we have 4 times 3 over 2. Which is same thing as 4 over 1 times 3 over 2. One of the easiest operation of fraction is multiplication. Why do we say so? Because you just multiply numerator times numerator, denominator times denominator. So we have that this is 4 times 3 gives us 12, and then 1 times 2 gives us 2. So 12 divided by 2 gives us 6. So that means for our numerator, this is 2 raised to power 6. How did I get 6? 4 times 3 over 2. Now for our denominator, we are going to multiply the power 3 times 4 over 3. So how that this is 3 times 4 over 3, which is still same thing as 3 over 1 times 4 over 3. Why am I expressing as 3 over 1? 3 and 3 over 1, they are still the same thing. Because 3 divided by 1 still gives us 3. I'm expressing it so it looks like this fraction. Now we can multiply 2. 3 times 4 gives us 12, and 1 times 3 gives us 3. 12 divided by 3 gives us 4. So we can see that our denominator is 2 raised to the power of what? 4. How do we get 4? 3 times 4 over 3. So now you can see that at this point, it has what? At this point, we can make use of our quotient law of indices. So our quotient law of indices, we have 2 raised to the power 6 divided by 2 raised to the power 4. Because their base are same, we can go ahead to subtract their powers. So we have that this is 2 raised to the power 6 minus 4. So 6 minus 4 gives us 2. So our final answer is 2 raised to the power 2. Now we can't leave our answer like this because 2 raised to the power 2 is equal to 4. So our final answer is equal to 4. So that means 16 raised to the power 3 over 2 divided by 8 raised to the power 4 over 3 gives us 4. And finally for this section, we are going to be simplifying 32 raised to the power negative 2 over 5. How do we tackle such questions when we see them? Please follow closely. Alright, so we are going to be solving the last question, which is question 3. Question 3, we are asked to simplify 32 raised to the power 3, raised to the power 2 over 5. Now looking at this question, this is a question on what? Negative what? Power. Negative what? Negative power. Now, the law of negative power tells us if we want to cancel out that negative power, all we need to do is what? We say 1 divided by what? The item there. But the first thing I want to show you is that this 32, we can express 32 in terms of 2. Just like how we've been expressing 16 and 8. Now, how do we do? I don't just want to say 32 can be expressed as 2 raised to the power 5. But no, let me show you. Now, you can see that 2 times 2 gives us 4. 4 times 2 gives us 8. 8 times 2 gives us 16. And 16 times 2 gives us 32. So we can see that 32 can be expressed in terms of 2. I'm saying 2 2 raised to power, how many times? 1, 2, 3, 4, 5. So 2 raised to power 5. So 32 can be expressed as 2 raised to power 5. Now we can rewrite this expression to be, instead of using 32, can I use 2 raised to power 5? So we can say 2 raised to power 5 all raised to power negative 2 over 5. Now it looks less complex. Now this point we can go ahead to apply the power of power law. When a power is raised to another power, what do? We multiply both powers. Don't forget this power is negative. So take it into consideration. So we have that, let's multiply the power. The power here is 5 times negative 2 over 5. So we have that this is 5 times negative 2 over 5. Which is same thing as what? 5 over 1 times negative 2 over 5. Now, because it's multiplication, we multiply through. 5 times minus 2 gives us minus 10. 1 times 5 gives us 5. Now, minus 10 divided by 5 gives us negative 2. So we can see that 5 times negative 2 over 5 gives us minus 2. So we can now write that this is 2 raised to power negative 2. At this point, we can now go ahead to comfortably apply the negative index law. Where if we want to convert this negative power to a positive power, what do? We use 1 to divide. So we can say that this is what? 1 over 2 raised to power 2. Now, because we have introduced this numerator 1, our power is no longer negative but positive. We simply took the reciprocal. And our final answer gives us 1 over 2 raised to power 2 is 4. And this is our final answer. We've come to the end of this indices series. If you have any question, I want you to drop your question in the comment section. And I also want to also recommend you and advise you to go check out the laws of indices on Elite Tutor Part 1 and Part 2 before coming to watch Part 3, so as to help you understanding on the various laws of indices. See you on our next video. Thank you very much. Don't forget to like, share, and subscribe.